Let's go one step up to the next isolation level, which is called read committed. As you can probably guess, this one specifies that transactions may not perform dirty reads. They may only read data values whose updates by other transactions have been committed to the database. Now, this isolation level is stronger, but it still doesn't guarantee global serializability, and let's take a look through an example. Our first transaction, T1, is the same one modifying the GPA for students from large high schools. Our second transaction is the one where we're going to reset the isolation level, in this case to read committed, and it's going to perform two statements. One of them is going to read the average GPA from the student table, and the other is going to read the maximum GPA from the student table. So let's look at one behavior that's consistent with the isolation level, but we'll see is not serializable. Let's suppose that this average GPA is read before transaction T1, but the max GPA is computed after transaction T1. So the average will not take into account the increases, but the max will take into account the increases. So let's see if this is equivalent to any serial order. Is it equivalent to T1 followed by T2? Well, it's certainly not, because T2's first statement is reading the state of the table before T1 and not the state of the table afterwards, although T2's second statement is reading the state of the table afterwards. Similarly, it's not equivalent to T2 followed by T1 because T2 is reading in its second statement the state of the database after T1. So there's no equivalent serial order, but again, perhaps that's not needed for the particular application, and by using read committed, we do get somewhat more performance than we would have if we were serializable.